In this video, we're going to start looking at systems of two linear equations. So let me remind you what form a linear equation looks like. A linear equation can be in the form y equals mx plus b, and we would call that the slope-intercept form of a line. Or we can have standard form where we have ax plus by equals c, and a, b, and c are real numbers. So your lines can be in either of these forms, and what we'll look at is two of these linear equations and what would be a solution to both at the same time. We'll start with determining if an ordered pair is a solution. A system of two linear equations is a pair of linear equations, meaning there's two of them. And an ordered pair is a solution to the system only if it satisfies both of the equations. So when we talk about an ordered pair, we're talking about an x value and a y value. To test whether or not an ordered pair is a solution, you'll plug the x and y value in to your first and second equations and see if it makes them both true. So here's our first example. We have the system of linear equations 3x minus 2y equals 7 and y equals 2x minus 8. We're asked, is the ordered pair 9, 10 a solution to the system of equations? So 9 is my x value and 10 is my y value. So what I want to do is actually plug in 9 for x and 10 for y. So I'll start with the first equation, which is 3x minus 2y equals 7. So I'll do 3 times 9 minus 2 times 10 equals 7. And I want to see if that's true or not. So what I end up with is 27. 3 times 9 is 27 minus 20 equals 7. And that's true. So that is good. Now I'm going to take the second equation, which is y equals 2x minus 8. Y is 10. So I'll have 10 equals 2 times 9 minus 8. So I'm using the x and y values in this ordered pair, 9 and 10. And I want to check. 10 equals 2 times 9 is 18 minus 8. 10 equals 18 minus 8. That is also a true statement. So I would say that 9, 10 is a solution. And the reason it's a solution is because it satisfies both equations, not just one equation, but both. So using that same pair of equations, let's test the ordered pair 2, -4. So here x is 2 and y is -4. My first equation is 3x, so 3 times 2 minus 2 times y, so minus 2 times -4 equals 7. And we'll go ahead and work that through. So 3 times 2 is 6. -2 times -4 would give me a positive 8. 6 plus 8 is not equal to 7. So I would go ahead and say, no, that's false. And so automatically 2, -4 is not a solution to this system of equations. Let me show you, though, that it is possible for it to be a solution to one of the equations and not the other. So my second equation, y equals 2x minus 8, I'll have -4 equals 2 times 2 minus 8. So -4 equals 4 minus 8, that one checks out. But because this first one is not satisfied, we would say that 2 negative 4 is not a solution. It has to satisfy both equations. So even though it was a solution to the second equation, because it was not a solution to the first equation, it was not a solution to the system. Let's look at our types of solutions we might see for a system of equations. We have 3 possibilities for our types of solutions. When looking for solutions to a system of linear equations, there are 3 possibilities. The first one is consistent independent. Another word for that is a unique solution. And when that happens, it's 2 lines crossing at a point. And when that occurs, when 2 lines cross at a point, that ordered pair is going to be the solution. The place where they cross will be the solution, the x and y value. This example is y equals negative 2x plus 2 and negative 4x plus 3y equals 16. So try to memorize these terms, this terminology. Consistent independent means one solution or a unique solution. The second possibility is consistent dependent, and that's also known as infinitely many solutions. That happens when the equations are actually the same line. For example, we have 2x minus 4y equals 8 and negative 6x plus 12y equals negative 24. Now, if I solve for y in both of these equations, I would end up with the exact same line. This line is graphed here, and because they come out as the exact same line, we know that there are infinitely many solutions, meaning that any ordered pair on this line will satisfy both equations. Our last possibility is inconsistent, which means that there's no solution. That happens when 2 lines are parallel, meaning that they have the same slope, but different y-intercepts, and so they never cross each other, and so there's no ordered pair that will satisfy both equations at the same time. We'll look more at how to figure out which of these 3 cases you're in by using methods of solving. In future videos, we'll look at that.